Groundwater is essential to life in Nebraska. It sustains our agricultural economy, supplies most of our drinking water, and feeds our streams, rivers, lakes, and wetlands. Groundwater is stored underground in aquifers, and Nebraska's aquifers are among the largest and most productive in the world. Protecting these aquifers helps ensure future prosperity while maintaining the quality of life for all Nebraskans. But we can't protect what we don't completely understand, and because aquifers are hidden underground, they can be difficult to map and characterize in ways that enhance our understanding. Geologists have long sought ways to understand aquifers. In the early 20th century, advancements in technology made it possible to drill test holes thousands of feet deep. Geologists at the Conservation and Survey Division at the University of Nebraska-Lincoln began drilling test holes in the 1930s to retrieve samples and describe how water was stored in these materials. Through this statewide program, they were able to map the major aquifers and develop a basic understanding of groundwater in Nebraska. Test hole data provides valuable detail for the study of groundwater, but there are limitations. It's not possible to drill test holes everywhere. It's just too time-consuming and cost-prohibitive. This leaves big gaps in our understanding of the subsurface. In some areas, test holes are spaced several miles apart. Some gaps are too big when addressing modern challenges related to groundwater quality and quantity at the scale of individual farms, villages, and wellhead protection areas. These issues are often quite complex and require high-resolution data to build models and make good management decisions. In the late 2000s, a new era of aquifer mapping arrived, one which would make it possible to see into the subsurface in the spaces between test holes. This game-changing technology is called Airborne Electromagnetics, or AEM. AEM provides high-resolution data that fills data gaps between test holes. AEM surveys can cover hundreds of miles in just days, saving a lot of time and money. Nebraska has been a world leader in deploying this technology for aquifer mapping. AEM works by the principle of electromagnetic induction. A large loop of wire called the transmitter is towed by a helicopter. It emits an electromagnetic signal that interacts with the Earth, creating secondary signals. These signals are received by a smaller loop of wire called the receiver. The received signal is measured as tiny voltages. It's like calling out loudly and then listening for a faint echo. These echo voltages are transformed into a model representing the electrical properties of the subsurface. These properties help us map the geological materials below the ground in 3D. AEM has revolutionized aquifer mapping, but it does not eliminate the need for drilling, nor does it provide an exact measure of aquifer properties. Despite the great benefits of this technology, it too has limitations. To understand what the electrical properties are telling us about geology, we need ground truth information. Test holes and outcrops provide this ground truth, allowing geologists to transform the electrical properties sensed by AEM into hydrogeological properties that govern the flow of groundwater. So, test holes are still relevant today, even though AEM makes it possible to greatly reduce the number of new test holes necessary to map aquifers over large regions. We can say that AEM fills the gaps between test holes. Moreover, AEM helps us smartly select targets for drilling or aquifer monitoring rather than drilling blindly. AEM, together with targeted test hole drilling, has been used for many water sustainability and water quality projects throughout the state. For example, AEM helped inform a groundwater recharge project near Columbus, Nebraska. AEM was also used to develop a state-of-the-art groundwater flow model for the Lower Elkhorn Natural Resources District. The Middle Republican Natural Resources District is also using AEM in its planning efforts, as are several districts in the Lower Platte River Basin. AEM is also used routinely to locate wells for municipalities, farmers, and rural residents. AEM can save money for farmers, public water suppliers, and rural residents seeking to install new wells by ruling out locations that are unlikely to yield water to wells and reducing redundant test hole drilling costs. Without AEM, we are blind to most of the subsurface. AEM fills data gaps, saving valuable time and money, and it is used to create 3D models of our aquifers. Such models help us to make better decisions about protecting groundwater quality and quantity, helping to maintain quality of life for future generations. And, much like test holes, AEM will leave a lasting legacy of valuable information for generations to come.